Hello students, in this video we will see chapter number 3 in indefinite integration. यामध्ये आपण 2022च्या क्वेश्चन पेपर मधले काही प्रॉब्लेम्स या टॉपिक वरती आलेले आपण सॉल्व्ह करतोय. टॉपिक एकंदरीत 10 मार्कांना विचारला जातो, ज्याच्यामध्ये 2 मार्काचा एक प्रश्न असतो, 1 मार्काचा एक, 3 मार्काचा एक आणि 4 मार्काचा एक. तो आपण क्वेश्चन नंबर 1 मध्ये आलेला हा क्वेश्चन आता इथे सॉल्व्ह करतोय. याचं सोल्युशनही आपण आता इथं फाइंड आउट करतोय. So please watch it. Suppose I be the integral dx upon 4x square minus 1, and value of that integral is given to us. So I have considered I to be the LHS. That will be 1 upon 4 because 4 is constant. So if you take outside, it will be dx upon x square minus 1 upon 4 only. Okay, so this can be written as 1 by 4 into integration dx upon x square minus 1 upon 2 square. So value of this integral is nothing but, so 1 upon 4 is constant, and value of this integral is nothing but log of x minus 1 upon 2 divided by x plus 1 upon 2 plus c, by the formula that we have written here. Now this will be 1 by 4 into log of, this can be written as 2x minus 1 upon 2 divided by 2x plus 1 upon 2 plus c. So this 2 is cancelled with this 2 because in the numerator and denominator the same quantity is there, so we can cancel this. This will be 1 by 4 log of 2x minus 1 upon 2x plus 1 plus c. So value of the integration is given to us, and that is a log of 2x minus 1 upon 2x plus 1 plus c equal to half, sorry, 1 by 4 into log the desired value, calculated value 2x plus 1 plus this c is cancelled with this c1, and after comparison these come with this one, so a is equal to 1 by 4. Within a minute you can calculate the value of a, so your answer will be 1 by 4 now. Now just see here, so it is 1 by 4. So for 2 marks this question is asked. Now we will solve next problem. So we will solve question number 2, sub question 3. If f dash of x is equal to x inverse, then find f of x. The solution, let f dash of x is equal to x inverse means 1 upon x. So that is given to us, and we want to calculate f of x. So taking integration on both sides. On both sides we'll get integral f dash of x dx equal to integral 1 upon x dx. Integration of f dash of x dx with respect to x is nothing but f of x by the property, and integration of 1 upon x is nothing but log of x plus c is the integrating constant. So एका स्टेप मध्ये एक मार्क तुमचा फायनल होऊन जाईल आणि एक मार्क अशा पद्धतीने तुम्हाला मिळवता येईल. यानंतर सॉल्व्ह करूया क्वेश्चन नंबर 22. तो विचारला गेलाय 3 मार्क साठी. Evaluate the integral dx upon 2 plus cos x minus sin x. Solution. So to solve this integral we will use standard substitution. By standard substitution, that is tan of x by 2 is equal to t. Tan of x by 2 is equal to t. That means if this is x by 2 will be tan inverse t now, therefore x will be 2 times tan inverse, so dx will be 2 1 upon 1 plus t square into dt. For dx, we get value of the dx and we get value of the uh, x also. So from this, and we know that sine of theta is equal to tan theta by 2 divided by 1 plus tan square theta by 2, and cos of theta is also known to us. Cos of theta is equal to 1 tan tan square theta by 2 upon 1 plus tan square theta by 2. So if we replace theta by x, only theta by x, so this will be sin x, and that is 2 uh, t upon 1 plus t square, and cos of x will be now 1 minus t square upon 1 plus t square. So the integration is actually integral dx upon 2 plus cos x minus sin x. So we have obtained value of cos x in terms of t and value of sin x in terms of t, and we have also calculated dx, that is 2 by uh, 1 plus t square into dt. So we will resubstitute all the values here. Suppose I be that integral dx upon what is that 2 plus cos of x minus sin of x. So this integral now becomes uh, integral 1 upon 2 plus 1 minus t square upon 1 plus t square. So value of cos x minus value of sin x is 2t upon 1 plus t square, and into value of dx is 2 upon 1 plus t square into dt. Now we have made this as, so if we want to take denominator be 1 plus t square, so this is 2 into 1 plus t square plus 1 minus t square and minus of 2t divided by 1 plus t square. So we have taken 1 plus t square as LCM of all these three terms, and we have 2 upon 1 plus t square for the dx. Okay, so 1 upon 1 plus t square in the denominator of denominator, and this will be cancelled with this one. So ultimately we will get this as 2 times integral 1 upon 2 plus 2t square plus 1 minus t square minus 2t into dt. So we will move towards the next one, that is 2 times integral dt upon, this is 2t square minus t square, is t square minus 2t is also there, and this is 3. Okay, so this can be written as 2 into integral dt divided by t square minus 2t plus 1 plus 2, and so we know that t square minus 2t plus 1 is nothing but t minus 1 bracket square, and this 2 is nothing but under root 2 square. Value of this integral is nothing but 2 into value of this integral is nothing but 1 upon under root 2 tan inverse of t minus 1 upon under root 2 plus c, the integrating constant. So this will be root 2 tan inverse, t means tan of x by 2 minus 1 upon root 2 plus c. So this is the required answer that we are interested for, integral dx upon 2 plus cos x minus sin x. Thank you very much. यानंतर क्वेश्चन नंबर 32 आहे, तो 4 मार्कांना विचारला. u आणि v दोन फंक्शन्स असतील, डिफरंशिएबल फंक्शन्स ऑफ x, आणि त्यांच्या प्रोडक्टचे इंटिग्रेशन हे इंटिग्रेशन बाय पार्ट्स रूलने रिप्रेझेंट केलेला आहे, आणि तो रूल प्रूव्ह करायचा आपल्याला, आणि त्याच्यानंतर छोटा एक्झाम्पल हे सॉल्व्ह करायचा. सो त्यामध्ये आपण सोल्युशन लिहितोय. सो सोल्युशन मध्ये. So to prove this part rule, let us write integral v dx equal to suppose w. Therefore, v should be dw by dx because integration and derivatives are reverse procedure to each other. Integration and derivatives are reverse procedure to each other. इक्वेशन 1 मध्ये आपण समजलंय की इंटिग्रल v dx इज इक्वल टू w आहे. तर दोन्ही साईडला सॉरी डेरिव्हेटिव्ह घेतल्यानंतर एलएचएस मध्ये इंटिग्रेशन कॅन्सल होईल आणि आरएचएस मध्ये त्याचं डेरिव्हेटिव्ह दिसेल. यानंतर आपलं कन्सिडरेशन असेल टुवर्ड्स द प्रूफ. कन्सिडर derivative with respect to x of u into w because we want some u into integral v. Okay, so for that purpose I have just mentioned this. D by dx of u into v is nothing but product rule of derivative, and this rule represents u into d by dx into w plus w into d by dx of u. Okay, by using equation 2 we can write, or we can write this as first dw by dx u into dw by dx plus w into du by dx. Okay, from equation 2 we will write u into v is because v is equal to dw by dx, and therefore in place of dw by dx in the above step we will write v plus w into du by dx remains as it is. So in the LHS we have d by dx of u into w. Now taking integration on both sides. Now taking integration, because integration and derivatives are reverse procedure to each other. So cancel a derivative in the LHS. We may take integration on both sides. We will get definitely uw into LHS and integral u into v dx plus integral in bracket w into du by dx into dx. So this is the integration. After taking integration of above step we arrived here. Therefore u into w means integral v dx, and that is equal to integral u into v dx plus integral, let me write du by dx first, then into w means integral v dx bracket close into dx. Now we will arrange the terms as, if we take this integral u into v dx in the one side, and it will gives us u into integral v dx minus of integral the bracket du by dx into integral v dx bracket close into dx. Hence we have proved integration by parts only. Integration by parts rule. So using this rule, we may find a derivative of the asked question, sorry, integration of the asked question. So let me just show you how to do that. Wait a minute. So using this rule, we have been asked to find out some integration, that is, hence evaluate the integral log x dx. Okay, so we want to evaluate that integral, so let me just write I to be that integral. हे इंटिग्रल सॉल्व करायचं म्हणजे इंटिग्रेशन पार्ट्स रूल यूज करायचा. हे इंटिग्रेशन असं लिहिलं जाईल, इंटिग्रेशन लॉग ऑफ एक्स इंटू 1 into dx. Okay, basically this rule is applicable on LIATE Okay, so L stands for logarithmic functions, I stands for inverse trigonometric functions, A stands for algebraic functions, T for trigonometric functions, and E for exponential functions. So clearly we have log of x, that is the first function. So I have chosen this as a U and this as a V. So there is no second function. It should be always taken as a one. That will be the second function. So by using that rule, uh, which is clearly mentioned here now, we have proved also u into v means u into integral of v dx minus integral in bracket du by dx into integral v dx into dx. Using this, we arrived here. So log of x into integral 1 dx minus integral d by dx of log x, d by dx of log x into integral 1 dx into dx, okay, is equal to log of x into integral 1 dx is x minus integral d by dx of log x is 1 upon x into integral 1 means x into dx. Now we will cancel this x with this one. So we arrived at x into log x, because log x into x, that is the product, and in product we may choose x to the left of log x. So this can be written as x into log of x minus integral 1 dx, and that is equal to x log x minus integral 1 dx means x plus c, okay, or we can write it as x log x minus x minus c. This is the required solution. So integral of log x dx is equal to x log x minus x minus c. So this is what we are looking for. Okay. So this is what we are looking for. Thank you very much.